Welcome to True Projects. In this video, we are going to explain about the project that is a study on the application of explainable AI on ensemble models for predictive analysis of chronic kidney disease. So before getting into the execution, first let us understand what is this project about. Chronic kidney disease, or we call it as CKD in short. It's a condition where the kidneys gradually lose their ability to function properly. Over time, this kidney damage, that is, this damage can become severe and may even lead to the kidney failure or end stage renal disease. CKD, that is, chronic kidney disease, is often linked to the other health problems like diabetes, high blood pressure, inherited kidney issues, or repeated infections. The problem is that in the early stages, most people don't notice any symptoms, which makes early detection really important. Timely diagnosis allows doctors and patients to make lifestyle changes or start treatments that can slow down the disease. Unfortunately, in many places, especially in developing countries, CKD is usually detected only when it has already progressed to an advanced stage. At that point, the only treatment options may be dialysis or a kidney transplant. Late diagnosis not only makes the condition harder to manage, but also creates a heavy financial and emotional burden for the patients and healthcare systems. This is why improving early detection and awareness is so crucial for managing chronic kidney disease effectively. And here, blood and urine tests can help to detect chronic kidney disease or CKD, but identifying it early and understanding the exact causes remains a major challenge. Traditional AI and machine learning models can predict CKD, but they often act like black boxes, giving results without explaining how they reach them. On top of that, they aren't enough diverse medical data sets, which makes it harder to develop models that are truly reliable. As a result, As a result, CKD continues to be a serious health global concern. It can cause serious complications such as anemia, heart problems, and a weakened immune system. Beyond the health risks, the disease also leads to high treatment costs and contributes to increased mortality, highlighting the urgent need for better early detection and explaining prediction tools. So, to overcome with all such issues, the system we are proposing is designed to predict chronic kidney disease in a way that it is both accurate and easy to understand. So here it combines it combines several machine learning models called ensemble models with the explainable AI, which helps to show why a particular prediction was made. The system uses a dataset from the UCI machine learning repository, which includes medical test results, demographic details, and other clinical information from both the CKD patients and also the healthy individuals. To make sure that predictions are reliable, we carefully handle missing data using advanced statistical techniques. We also address the issue of class imbalance where there are more health cases than CKD cases by using a method called SMOOT. This ensures that the system can learn effectively from both the CKD and non CKD samples, making prediction more accurate and trustworthy. Here, to make the predictions more accurate and meaningful for the doctors, the system first selects the most important features from the dataset. This is done using a combination of statistical analysis, correlation studies, and machine learning based models like information gain, variance, threshold, and recursive feature elimination. So, from this process, the system identifies six key indicators or biomarkers that are most important for detecting CKD. These include hemoglobin, serum creatinine, albumin, hypertension, age, and diabetes. By focusing on these critical factors, the model can make predictions that are not only accurate but also clinically relevant. And moving on, the system uses several machine learning models to predict the chronic kidney disease, that it uses logistic regression, support vector machine, decision trees, random forest, and XGBoost. And to make sure that these models are explainable, that is, these models aren't just black box, we use explainable AI techniques that are Lyman sharp. These tools show how each biomarker like hemoglobin or serum creatinine contribute to that predictions. So this way, doctors can understand the reason behind the results and patients can gain insights into the factors that affect their condition. And here, to further improve the performance of this project, as an extension, we are incorporating voting classifier, which is an ensemble model. This model, it combines predictions of individual models. So here in this project, we are combining random forest, support vector machine, and XGBoost. By doing this, we can take advantage of the strengths of each model to improve the overall accuracy and make the system more reliable in detecting CKD. And also we have developed a front end using Flask framework. We have built a user-friendly interface using Flask framework, which includes user secure login. And this allows users to easily input patient data and get predictions from the trained models, making the system practical and simple to use in a clinical or research settings. Moving on to implementation. To implement this project here, we have followed the steps which are mentioned in the flow of work. So let's understand how we have implemented the project. First, we have imported all the necessary libraries that will help with us in data analysis, visualization, building, and deployment. Then comes data exploration. So at this stage, we use chronic kidney disease dataset from the UCI machine learning repository, which will combine, that is, which contains the Apollo Hospital data and also the Indian data, which has the chronic kidney disease. So we analyze the dataset to understand its features, target variables, and also the data types. Then comes data visualization. At this stage, we visualize the distribution of the target values to see how many CKD and non-CKD areas, that is cases, are present. We also generate a correlation matrix to understand the relationship between features. Then comes data pre-processing. So at this stage, we will be handling missing values through data imputation and split the data into subsets that will be useful for analysis and model training. Then comes feature selection. So at this stage, we apply recursive feature elimination or RFE to identify the most important features that contribute to accurate CKD predictions. Then comes data balancing. Here at this stage, to make sure the model learns equally from both the CKD and non-CKD cases, we are using SMOTE to balance the data set. And we split the data into training and testing sets. And here we use tenfold cross-validation to split the data into training and testing sets, ensuring that every sample gets evaluated and the model generalizes well. Then comes model building and evaluation. So at this stage, we build machine learning models that are logistic regression, support vector machine, decision trees, that is decision trees, random forest, and XGBoost to predict the CKD. And coming to evaluation, we will be evaluating all of the models using accuracy, precision, recall, and FN score. And we also generate comparison graphs to clearly see which model performs the best. And the best performing model will be saved for the future use. And then comes explainable AI models. So here at this stage, to make the predictions understandable, we use Lime and Chap, which show how each feature contributes to the prediction. This helps clinicians and users understand why the model predicts CKD or non-CKD. And coming to the front end part, so here the front end is developed using Flask framework and it includes registration and login features using SQLite for secure user management. Users can input the feature values for a patient directly into the interface. The input is pre-processed so it can be used for the model, I mean by the model for prediction. The trained model predicts whether the patient is CKD or not. Finally, prediction result is displayed clearly on the front end to the user. And to implement this project, I mean to execute to predict the CKD, we have used these models, that is logistic regression, naive-Bayes, support vector machine, decision tree, random forest, AdaBoost, XGBoost, and the extension model voting classifier. And we need hardware and software requirements to implement it. So coming to hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And software requirements are application of Anaconda, primary language of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute. To execute, open the code folder that contains source code files. So let's open it. These are the source code files of the project. Let's understand each of them. In this folder, we have the dataset that is used. Here it is in these files, and we will be extracting data from that. And here we have model folder in which we have algorithm information that will be loaded into the project code during runtime of the application. Here we have static folder in which we have CSS, JavaScript, and Bootstrap files which are important for the project's visual appeal. And here we have templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have test cases that we will be using in the front end for prediction. Here we have app.py file. So this .py file, it contains the information related to front end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. Here one is the RF file, and here we have notebook file, which is a Jupyter notebook file which contain a combination of code, graphs, and outputs all in one place, and it allows users to write and execute code in individual cells, making it a popular choice for the data science. This is a sample file, and here we have signup.db file. This file is a database file that is used to store the user information. So this is all about the code folder. Now let's execute. So copy the path of the code folder from the address bar of the file explorer. I'm copying it. Now open Anaconda prompt. So it is open. Now give the command cd, give the space, paste the copied path, click on enter. Here you can observe current directory is changed to the code folder's path. Now compile app.py files using the command python space app.py and click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So copy the local link provided by the Flask framework and paste it in any web browser. I've copied it. I prefer Google Chrome, so I will paste it in that. Paste the link here. Now click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So we need to get registered. So click on register and create an account. I have already created account. So to create an account, you need to fill in all these details. As I have already created, I'll directly sign in. Click on sign in. Give your username and the password. Click on username and the password and then click on login. We have signed in successfully and redirected to prediction page of the project. So here you can see multiple parameters that are need to be given as the input to predict the chronic kidney disease. The first one we have is the hemoglobin. This tells us the level of hemoglobin in the blood. Low levels can indicate anemia, which is common in people with kidney problems. Then we have serum creatinine. So the next value is serum creatinine. This measures how well the kidneys are filtering waste from the blood. High levels can be sign of reduced kidney dysfunction. And then we have albumin. So it is a protein in the blood. Low levels may indicate the kidney are leaking protein, which is a sign of kidney damage. Then we have hypertension. This shows whether the person has high blood pressure. Persistent hypertension can cause, that is, can both cause and result from the kidney disease. Then we have age of the person. Age is important because the risk of chronic kidney increases as people get older. Then the last one is diabetes mellitus. So it indicates whether the patient has diabetes. Diabetes is one of the main causes of kidney damage and CKD. So this is all about the parameters. Now let's enter them. For that, let's open the sample file. So open test cases, open samples. So here we have multiple cases. So let's apply filter to this. Let's freeze this. Let's freeze the first row. Now let's apply filter to this to predict the CKD. So now let's apply filter to non-CKD first. Click on OK and let's start entering the values. Here we have hemoglobin as 15. So let's enter that 15 as hemoglobin. Serum creatinine is 1.2. Albumin is 0. Hypertension is no. Age is 40 and diabetes mellitus is no. Now click on predict. So this given information, it will be pre-processed at the backend. It will be fed to the trained model and trained model will be giving us a prediction. So here we got the prediction that there is no chronic kidney disease detected. They can also suggest that there is no chronic kidney disease with a 79% confidence score. And this is the medical information. And here we have important warnings. And here we have recommendations and next steps what to do. Let's try doing new predictions. So click on that. And let's check with this case. So give hemoglobin as 15.4. Serum creatinine is 1.2. Albumin is 0. Hypertension is no. Age is 57 and no diabetes mellitus. Now click on predict. And here we got the prediction that it is no chronic kidney disease detected. Here you can see recommendations, next steps, medical information, important warnings. Let's try doing new prediction. So click on new prediction. Let's apply filter to CKD and click on OK. So let's check with this case where hemoglobin is 9.6, serum creatinine is 1.8, Albumin is 0, sorry 2. And we have hypertension as no. Age is 62. Diabetes mellitus is yes. Click on predict. And here we got the prediction that it is chronic kidney disease detected. And here we have medical information, important warnings, recommendation, next steps. If you want, you can also even print results. Now let's try doing new prediction. Click on new prediction. Let's try with this case. So let's see the hemoglobin. Let's enter it as 9.5. Serum creatinine is 7.2. Albumin is 2. He has hypertension. Age is 53. Diabetes mellitus is yes. Click on predict. And here we got the prediction as chronic kidney disease has been detected with a 92% confidence score. And here we have other recommendations. You can even print results. Now let's view the analytics. So click on view analytics to see the graphs. So here we have model metrics. Here on x-axis we have accuracy and on y-axis we have the all the models. It shows the accuracy of each model, and here we have precision weighted comparison graph, and here we have recall weighted, and here we have FN score weighted comparison graphs. And here we have model performance heat map. So here this is the heat map which shows the confidence score, which shows the correlation. Let's close this. And here we have parallel coordinates plot. This is the parallel coordinates plot. And here we have SHAP plot. This is the SHAP plot which shows the feature importance of each feature. Close this. Now click on log out. So this system, it helps to detect key problems early, that is key kidney problems early, giving doctors and patients clear insights so that timely care can be provided by understanding the key factors that affects kidney health. It supports better decisions and healthier outcomes for everyone. This is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.